Hey, what is up? GERO 508. Okay, so today is Saturday, July 8th, and I'm going to do my second lecture. I'm actually wearing my CLL Society shirt in honor of Julia. And so we're going to talk today about the interaction between the nervous system and the immune system, and the immune system and the nervous system. And it's bidirectional, and it can go haywire when you are under chronic stress. Okay. Um, it's very, very complicated. I'm going to show you this, okay, and straight up. And we've provided lots of resources. You guys are smart. You guys are grad students, and you can just kind of sift through them and use them as best you can. Just one it's a slightly older article that has lots of really good figures, but it's really complicated. I don't want you guys to bury yourselves with that article, okay? Just warning you about that straight up. All right, very cool. So yeah, I'm getting nervous. 2 days away from surgery. We've gotten lots of good interaction from everybody here in class. People sending really good thoughts, sending prayers. We actually have a pastor who sent a really nice email to us to give us his blessing. And but yeah, we have a lot going on. I actually, as you know, I'm going to have surgery on this right shoulder because of this funky bicep. I did something to my left wrist, and I can't put any weight on it. I actually went to go see the surgeon yesterday, and it was getting better. I did it on July 4th, actually just doing something like this with a bag to open it up and put it into a trash can. And it was getting better, and then he went and manipulated it and sent me backwards in time, so I can barely even hold the phone right now. All right, but that's my good hand because this is the one I'm having surgery on. I don't know. I am conflicted, to say the very least. And yeah, it's a weird time. You guys are going to see us through this. We'll see what's happening. It's probably really severe carpal tunnels um, typing my whole life since I was, a very young scientist, and then I just exacerbated it with a very acute wild motion, and now I'm in trouble. But anyways, we gotta marshal on. So that's my story here, and we're going to go into the psychoneuroimmunology chapter. Now, what I've done in this chapter, guys, this is really cool stuff. I mean, I know, sorry, it's right here, and then this explains what's going on in terms of the midterm exam, okay? Um, and so, what this section is all about is, and again, this right here explains to you the midterm exam on July 17th. I think I got that right. I want to actually check right here. Let's see what it says over here. July 17th. Perfect. Okay. It covers all this material right here, and it's just a repeat of the very same quiz questions you had. It's just repetition, repetition, repetition. Okay. I'm just letting you guys know that. All right. So nothing to fear about that. Okay. So let's go into psychoneuroimmunology. We looked at the link between diabetes and stress. Okay, we know all about that. We know how um, when you are in a very stressful situation, okay, you mobilize your resources, okay, increase your breathing rate, your heart rate, your brain activity levels. Your pupils get fully dilated. Um, and that comes at a cost of needing lots and lots of fuel, rocket fuel in the form of glucose. And that's where the cortisol goes running to your liver and says, let's release some of that rocket fuel, okay? Um, and the idea is that the stress will be over pretty quickly, maybe within a minute or two, okay? And then things can go back to normal. Okay, that's the idea. And long term, however, if you have elevated cortisol, elevated free fatty acids, and today what we're going to be talking about is cytokines, okay, that get elevated when you're under long-term inflammation that happens with stress. That can then cause a permissive effect for the type 2 diabetes because it makes your insulin receptors insensitive to the action of insulin we saw last time, and that was because even though insulin binds to the receptor, the signal that goes inside the cell to open up the channel to suck in the glucose, it gets derailed basically. Okay, so that's not a good thing, and John talked about all the consequences. Anywhere there's a blood vessel, you got problems. Okay, you can get peripheral neuropathy. Okay, I got that wrong kind of a little bit last time, and that's where the nerve cells die way far away in the far away blood vessels, and this has to do with the effect of the atherosclerosis mediated by diabetes going all the way into your lower limbs, and you don't get enough oxygen down there, and because the blood vessels are all constricted from the atherosclerosis, and the nerve cells begin to die off. You're more likely to get infections too because you can't get the immune system down there because of all the goo in your blood vessels. Okay. All right, that was just one example, but it goes on and on and on and on. And when there's a blood vessel, you got a problem. Strokes, heart attacks, okay, that happens when you have the combined atherosclerosis, and then a piece of the plaque can go off, and it forms what's called here's a hole, and the plaque goes and forms a plug in the hole called an embolism, and that type of clog will then cause what's called an ischemic stroke or a heart attack, and on and on and on. Okay, low levels like that happening in little capillaries leads to dementia. So that was all kind of all connection. Now, all connected. Now, part of this whole scenario too is if you're chronically in an inflammatory state, okay, causes lots of health consequences, causes this vascular disease, can lead to cancer, on and on and on and on. Okay, so let's take a look at this one right here. All righty, so it's called psychoneuroimmunology. This is a relatively new field. It's enormous, okay, and there's nothing more complicated than the immune system, believe me. Even more complicated, I believe, than the nervous system, and we don't know a whole lot about the nervous system. The knowledge we do have in the immune system allows us to do really special approaches to treating cancer, for example, by understanding how the immune system attacks cancer cells. And that's basically what, the specialized treatment that Julie's undergoing this week, okay? So I'm going to tell you straight up, a lot of knowledge needs to be acquired before we really know exactly what's going on. What I've done down through here is I've given you my best overview of all the information that we have right here, okay? Alrighty, and so it just goes, it starts with, again, the concept of this class is a mind-body connection, okay? So we're gonna look at the interaction between the nervous system and the immune system, okay? And the fact that it is a two-way street. So when you activate, remember the adrenaline rush, which is the part of the autonomic nervous system, okay? It's the sympathetic limb that releases adrenaline. That causes a chronic inflammatory state, okay? That releases these little tiny chemical messengers that go all throughout your body and cause an alarm to go off in terms of the immune system. And you don't need that, okay? Because the immune system has the best intention, but it can overshoot its mark and cause problems. For example, all the different autoimmune diseases that are out there, whether it's multiple sclerosis, irritable bowel syndrome, psoriasis, arthritis, all these things can be made worse when you're chronically stressed, and that's been shown over and over again. All right, very cool. So we have this autonomic nervous system, as I indicate right here. It has two limbs, okay? So I was talking about the fight or flight response, okay? When you have an injury, you want your immune system to be crazy mobilized, okay? There's nothing more stressful. So I'm going to have major inflammation when I have surgery here. I have major inflammation going on in my wrist right now. It's all hot, it's red. It's a tough decision. Like I said, I don't know where to go with this thing. I'm gonna need a lot of help, and then my boys are gonna have to kick in. Okay, we're gonna stay the course. Okay, guys, we're gonna figure this thing out. But the sympathetic nervous system is sent into alarm. So I'm going to have lots of stress when I have surgery. It's not only the psychological stress, but it's you have a physiological stress. For example, if you were to go outside in somewhere in Arizona right now and the temperature is 110, you actually activate that very same stress response because your system is being prodded in a really bad way. You're poking the bear, okay? I'm going to be doing that with my surgery, so I'm going to have lots of stress. I'm going to have lots of global inflammation. And then when you have a wound, your job of your immune system is to go in there and repair the wound and get rid of all the debris from the surgery and stimulate cells locally, stem cells, to start reproducing and form brand new cells in the area that has been surgically manipulated. So that's going to be going on with me. All right, so this part of this message is this pro-inflammatory messenger called cytokines, okay, that are triggered by the release of adrenaline or noradrenaline, also called epinephrine and norepinephrine, okay. This is a very simplistic view. I'm just warning you guys. There's other types of things that happen, okay. We also remember we heard about cortisol and the hypothalamic pituitary axis, okay, and there's tons of controversy. And I just wanted to show you, there's too many papers to show you right now, guys, but I'm just, oops, I'm gonna look right here, this one right here. So it's pleiotropic, meaning it goes both ways, okay? Effects of cortisol, which is a glucocorticoid on the immune system during our normal rhythms, okay? We have a normal rhythm of stress response released, okay? So to give us sugar when we wake up in the morning, so right before we get up in the morning, poof, cortisol gives us a little burst, and then we have sugar so we can get going, all right? But during stress, it's chronic and it's elevated, it's all the time, okay? And it has good and bad effects, okay? So that is the controversy, okay? We know that, that you can inject steroids and to reduce swelling. We all do that, okay? So that is the good effect of a super high concentration that was discovered by science, okay? You also know that your doctors say we can only do this so many times, okay? Because the chronic long-term effect of having those steroids can be health compromising, all right? Alrighty, so when you have chronically middle range elevated steroids from stress, it can actually cause hyperactivation of the inflammatory response, okay? So we see this kind of double-edged sword based on how much. That's what pleiotropic means. It means in one way, it can have one effect, in another way, it has another effect. So we know that we use it clinically to reduce inflammation, but you can't do it a whole lot, okay? But we also know that stress at the level of what happens when you're psychologically stressed puts us on the other side. And I kind of showed this down here before I get into this really quick Healthline article that really helps to summarize things. I show it down here right now. And these are different models, okay? So this is physiological right here, okay? All right, like I said, this is pharmacological. This is the doctor injecting a joint with huge amounts of steroids that causes this reduction of inflammation, okay? We see right here that in the early phase, physiological, and during stress, okay, it goes like this. Now, what we see here are two different lines, okay? This is somebody that has a chronic condition that is high stress, PTSD, anxiety disorder, or clinical depression. You see that they have chronic inflammation that goes up really high under these levels of blood cortisol. This would be somebody that's quote unquote normal. Well, they get an inflammatory response, but it quickly goes down based on the concentrations. You have this differential effect, okay? All right, so we see here the activity of immune defense mechanisms, okay? So we see these permissive actions, okay, in terms of normal levels of cortisol right here. I'd put it right here in the end. During stress, okay, it can have this huge activation part right here, okay? And then what happens in this study, again, with super high concentrations beyond the normal stress levels out here, then you begin to suppress immune activity. Lots of controversy, okay? Okay, so that's just the level of cytokines. If you're out here suppressing immune activity, then you're more likely to get infections. And that's been shown as well too, all right? People that are under stress while they have a chronic inflammatory state, there's a whole subset of immune system cells that are supposed to help guard you against infection that get derailed by that high stress. So you have all the signals that create the inflammation that causes toxicity and problems, but then you are tweaking the key fighter pilot immune system cells that are going to go in there and go after the infection. So as a result, you're in this chronic inflammatory state, and you're not fighting off infection. And then as the infection rises, then you get more inflammation. And so you can see this is a very snowbally effect. All right, very cool. All right, so that's what that's all about. So we come back up here, and again, I prefer going to the actual Healthline article right here. And it talks about psychoneuroimmunology, okay? And like I said, it is a relatively new field of study. It's really exciting, okay? It's something to understand, okay? And it's something that we, when we're looking at meditation, I saw a couple of you guys did meditation articles in terms of your research article, which was really cool. Those types of intervention, music, which is a form of meditation, we're trying to control these abnormal interactions between the nervous system and the immune system. Okay, so they go through it here in a very simple way, and then they talk about some research articles that you can link to if you have an interest. Okay, so there's tons of new research looking at the effect of stress on the immune system. Okay, like I said, this cytokine is a small, little, tiny protein released by immune system cells. It's also released by other tissue too, your liver, vascular cells. Okay, to activate the immune system. Okay, and the immune system activates other parts of the immune system, all right? And that's what that's all about. So these are called pro-inflammatory cytokines, okay? They're going to initiate. And what is inflammation? Inflammation is we want the entire immune system to be active and racing towards the area that's causing the problems. As needed, we're going to have all kinds of cell division, increasing more immune system cells. And so when you're in high stress conditions, if you were to do a white blood cell count, and your white blood cells are a measure of your immune function, you would see an elevated level number of white blood cells, okay? And it would differ between whether or not it's the myeloid cells like your neutrophils and your macrophages. More likely also your lymphocytes would be highly elevated, okay? Alrighty. So we release these cytokines, right, in response to, like I said, an infection, all right? So if you got COVID, your white blood cell count would be high. There'd be lots of cytokines. This is a stressor, okay? Or injury, like a surgery, okay? Like what's going on with my wrist right now, all right? And it's in there to kill the germs, virus or bacteria, or to repair the tissue that's damaged, okay? Alrighty, when you're physiologically or emotionally stressed, okay, we see epinephrine right here, also known as adrenaline. They actually can bind to cells that are going to modulate the production of these pro-inflammatory cytokines, all right? That's the exciting new part of research, looking at that. So they go over a bunch of articles right here that you can look at that kind of support this concept, okay? And then they look at examples of psychoneuroimmunology and how we can maybe control this abnormal immune response that has been being mediated by an activation of the stress response, okay? We're focusing on just the adrenaline part or the rest and digest part that can cool its jets, which would be the acetylcholine part. So an example right here is an autoimmune response, okay? So this would be psoriasis, okay? And so they talk about psoriasis being lots of release of pro-inflammatory cytokines by the immune system that trigger this autoimmune response, okay? Same thing can be said with Crohn's disease, irritable bowel syndrome. Same thing can be said with, I have a friend that has multiple sclerosis, high stress conditions. She has exacerbated or increased in multiple sclerosis, okay? Studies are now linking cancer to high levels of stress linked to the pro-inflammatory state, okay? We know that coronary artery disease, okay, is a inflammatory disease, okay? And so we see lots of information at the site where plaques are developing, okay? And like I said, it is a growing field. So anyways, that's what that's all about. So that's kind of a quickie overview, all right? Very cool. Alrighty, so then I go into this description of white blood cells, what it all means in here. So read through this, okay? We get into this article. This is a really complicated article, and I want you to just breeze through it. Don't get caught up in the details, okay? I just want you to give an understanding. It's a cool article though because of the figures, okay? And that's what I'm going to go into right here. Okay, it's called the inflammatory reflex, okay? and and it's a review article. Okay, it was from a while back. Okay, it's still very relevant. Okay, and it just goes through disease conditions over here on the left. Okay, and it talks about the interaction between our autonomic nervous system and the production of cytokines that activate the immune system, and also how those immune system cytokines in turn go back and change their nervous system function. So this two-way pathway. TNF, tumor necrosis factor, TNF alpha, is one of the more famous ones. It's actually released in really high contents when you have an infection or when you have an injury. Okay, this is the one that is targeted by one of the more common biological therapies for autoimmune disease, and it's called Humira. And Humira is an antibody that you do an infusion on with once a month, once every 2 months, and then what it does is it reduces the amount of TNF alpha in your bloodstream so that you're not going to activate autoimmune cells that's causing your problem like rheumatoid arthritis or your problem like Crohn's disease or whatever your autoimmune disease might be. Now, TNF alpha is also released when you have a major infection, so you can guess that when you're on these drugs, you are immune compromised. All right, so they go through a lot of complicated discussion about this. Okay, they look at they talk about diffusible anti-inflammatory mediators. So these are these guys right here, the cytokines, but we also have lots and lots of hormones that modulate it. This is locally with damaged tissue. That's what this is. You don't have to know about it, but these are hormones, and the two ones we've talked about is cortisol and adrenaline and noradrenaline. Okay. All right, we don't have to worry about alpha MSH. All right, cool. All right, so therapies are out there. I just talked about Humira, monoclonal antibodies against TNF alpha, okay, that modulate that response, okay? Now, it's in this discussion right here, they also then talk about the anti-inflammatory responses that normally inhibit inflammation. Okay, so there's two ways of going about this. Okay, so you do have hormonal mechanisms for reducing inflammation. All right, there's communication between the immune system and nervous system. They talk about that. Okay, alrighty. So what I wanted to do is to get in there and give you a little feeling of kind of, because I'm very visually oriented, of this autonomic sympathetic nervous system. All right, so the autonomic nervous system that has both the sympathetic and the parasympathetic. Fight or flight is the sympathetic, rest and digest is the parasympathetic. All right, so one of the bigger parasympathetic nerves is our vagus nerve. Okay, it goes down to the gut and it enhances gut motility. It's what is really active during the rest and digest phase. Okay. And what has been shown, okay, is if you can have this relaxed, rest and digest mentality all the time, okay, so you don't have to be eating all the time, but if you can just cool your jets, you do release acetylcholine, and acetylcholine comes down here and binds to immune system cells, okay, and what it does is it reduces, see that's that little bar, it means it's going to inhibit the release of these cytokines, okay, that cause inflammation throughout your body, all right? And it can do this all throughout. Okay, so they're showing right here its action in the gut. Okay, but there are actions of heart, liver, and spleen as well. All right, cool. Let's go on. And again, you can read about vagus nerve stimulation as a method used to suppress the immune system. So this is being tested for treating autoimmune disease. Vagus nerve stimulation also is used to treat clinical depression. Going the opposite way, this rest and digest process allows you to calm down. All right? All righty. Cool. All right, so we're then now again looking at the action of the nervous system down here on an immune system cell. Okay, so this was my rest and digest pathway that releases this ACH, which stands for acetylcholine, and that reduces my cytokine, the TNF alpha, okay? However, conditions of pain is a very much a threat, an arousal, a fight or flight response, and so you have high levels of TNF, like I have right now because of my tweaky wrist, okay? And then when you're really stressed out, you can have this bimodal action right here, but mostly an increase in TNF alpha as well, all right? We then have over here glucocorticoids, okay? Um, they have differential effects, and it's controversial, like I said, okay? They can have an immediate reduction in the activation of some immune system cells so that you're more vulnerable to infection, but they can also increase kind of a nonsense aspect of inflammation, all right? Alrighty, so they go through all this, and then this is just a reiteration, okay? Acetylcholine, okay? When are we gonna have this inflamed zone, this immune system that's going crazy, okay? We're gonna have it during infection, injury, maybe after a heart attack or a stroke, and this is what the ischemia means right there, okay? Alrighty, so we have the release of acetylcholine, and that reduces it, okay? If you have a lot of the cytokines, TNF alpha, interleukin 1, interleukin 6, these are pro-inflammatory cytokines, they will actually activate the nervous system, course back up to the brain, and cause you stress, okay? Make you anxious, contribute to clinical depression, okay? And when that happens, then you're more likely then to be releasing this right here, okay, all right, and activating this system right here, okay, the adrenaline and noradrenaline, okay, all righty. And it has, like I said, a very controversial but not great effect on your stress system, right? All right, so maybe we can take these approaches, conditioning, biofeedback, meditation, acupuncture, okay, all these different approaches. They're going to modulate this nervous system interaction right here so as to reduce your inflammation. And that's what this last figure is all about right there, right? Awesome. So it's like I said, it's a very complicated paper. I want you to get the best you can out of it, put it that way. All right. Lastly, we come over here. This is going back to our good friend Sapolsky, and he's going to put it into a context of sociology. The good news is this paper is only about 1.5 pages long, okay? So he's studying macaque monkeys. Remember, he was looking at the rhesus monkeys, okay, when he was doing that documentary. And so not only was he looking at cortisol, and they were looking at heart disease, and we know that cortisol was elevated and heart disease was elevated. Then we also saw obesity in the subordinates. That contributed to pro-inflammation, okay? And when you look in here, he looked at in his pro-inflammatory subordinates. The bottom line in this article, you can just scroll through it, is social subordination, okay? Meaning you're very low in the pecking order and the totem pole causes pro-inflammatory changes in gene expression. So where does that go back to, okay? It means that it's at the epigenetic level, it's turning on the genes, okay, that will produce these little small proteins that are pro-inflammatory cytokines, okay? And so he talks about it all through here. You can test it right here by challenging it with a protein that is expressed on bacteria, and you see that primates that are subordinate have this crazy hyperactivation in response to an infection, okay? Alrighty, and so that's what it's all about. So, says the trials and tribulations and inflammatory states of rhesus monkey apply to us. Absolutely, of course they do, and that's the whole point of all his work. All right, so that's that article. Again, this goes over this concept of here I am injecting my joint with cortisone. Here I am injecting with cortisone. It's going to reduce the inflammation, okay? But high levels of stress are promoting for inflammation, okay? And it all has to do with the differential sensitivity of the stress response to cortisol. Okay, so this is just something for you to cruise in and take a look at. This is this promotion of programs to reduce stress, okay? Through meditation,
The cousin
exercise,
center is very interested
sociality.
in understanding the interactions between the brain, the body, and the immune system,
So
and the science behind that,
it is
and
super,
generating rigorous scientific evidence about.
super important. So you're going to see how studies are conducted. And then just right here is a long study. Um, watch it if you can, where Kavita Fedara, this is for a while ago, she studied psychoneuroimmunology and she looked at stress and she found that people that were stressed, that were in nursing homes, were much more likely to get really bad cases of the flu, all right? And also which were much more likely to suffer from ulcers and bed wounds and bed sores. So this is even though they're in this pro-inflammatory state, they're not mounting that specific action to fight infection, all right? All right, and this is from right here, this article right here. If you want to look at it, quick article on our website. USA News talks about how aging can really tip the balance if you've had a stressful life during your life in terms of the impact on the immune system. All righty, so you've gone through all this. The quiz is pretty straightforward and easy, and then you go through here and you address this concept of this chronic inflammatory state, okay? Kind of therapies that we do, how it might contribute to autoimmune disease, okay? All right, we think about all this right here. And what you did to kind of reiterate what you know about the nervous system and inflammatory cascade and how chronic stress might influence our immune response, okay? And that's what this is all about here, all right? And then I want you to take a look at that cousin's video and think not only about the goodness that happens in terms of heart rhythm, cortisol, with meditation, etc., but the goodness that's happening in terms of what it's doing to your immune system. And that's the whole point of this. There are so many tangents, there's so much not known, okay? But obviously this is a huge field that you should be aware of, okay? And the more we learn about it, the better off we are. The more you guys learn about it, the better off your clients will be when you're running your facility. So that's where we're at with that, my friends, okay? Peace, wish me luck, okay? And give me prayers. Hopefully I'll be all good. This is a very stressful time for me and Julia. Julia was upstairs and she was pretty tired today after her 2 days of infusion, and I think it's because it hasn't really kicked in. So her red blood cell count is probably plummeting right now. If you look at the normal levels of hemoglobin, I was talking to her about today, you should be around 13, 14. I think that's milligrams per microliter. I don't know the actual units, but everybody knows, everybody that does hematology knows they always will say bark off 13 or 14, and hers was at about 8. Okay, so it's that far below normal, and then if you get down to 7, 6, 5, then that's when you're going to have probably some red blood cells infused into you. Okay, so yeah, so it's a crazy time, guys. But I think you guys are there to support us and stay in touch. I may be having trouble typing. Well, we're going to do the best we can in terms of staying on top of all the amazing discussions. We're reading every discussion. We're looking at your guys' interaction. You guys are the bomb, and we're reading everything you do. All right, we take it all to heart. So, all right, peace, guys. Take care, and we'll see you next time.